Hey guys, welcome back. So in the last video we talked about types of an array. In that we discussed one dimensional array, two dimensional array and three dimensional array. We did not discuss four dimensional array and forward, and the reason is they are hardly ever used in real world. Now there was one question pending from the previous video, which was how does this array are represented in memory? Are they represented the same way as we see right now in these diagrams, or they are represented in a separate way in memory? Let's talk about this in this video. So we'll first start with one dimensional array. So let's say we have initialized an array which is containing 10 cells in it and having value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's see how is it stored in RAM. So let's say this is our RAM, that is random access memory. Now when we instantiate an array of 10 cells, all that the compiler does is it allocates 10 contiguous cells in this RAM. Now it can start from any of the cell. It can start from here, or it can here, or it can start from here, which is the case right now. So where will this array start in RAM? That is not in hand of programmer. But what the system guarantees is all these cells will be in contiguous memory location. So it is not possible that cell number 0 is over here and cell number 1 goes there and then cell number 2 comes here. Not possible. It will always be in one sequence, that is in adjacent cells. And why is that? Because that is the nature of array. Recall from the definition of an array that it will always be in contiguous memory location. So one dimensional array is an extremely simple case which we just saw now, that the compiler will allocate the memory from any random cell and then allocate 10 contiguous cells. Now let's see how does two dimensional array is stored in memory. So let's say we declare a two dimensional array with 5 rows and 2 columns having value starting from 0 till 90. So remember from the previous video what we said is that this is row number 0, this is row number 1, 2, 3, 4, column 0, column 1. Now in the memory, that is RAM, will it be stored in the same way or it will be saved in some other way? Let's see. So at a memory level it will be stored as a flat 1D array, that is row number 0, column number 0 comes first, row number 0, column number 1 comes second, row number 1, column number 0 comes next, row number 1, column number 1 goes next, and so on. It never gets stored in this format. Now this is only for understanding of user so that they can understand a 2D array better. So it is at a logical level, but at a physical level it is still stored in 1D array. So is it not interesting that the array which was looking completely different in the previous slide at a logical level is stored as a completely different way in the physical level? Now as you would have guessed that even in case of 3-dimensional array it will be stored as 1-dimensional array in a flattened manner. Let's see that. So we have an array here which has depth 2, rows are 3 and columns are 3. Now remember from the previous video we said that a 3D array is nothing but multiple 2D arrays combined into one. So you might be thinking that this current array, which is ARR233, will look something like this. But this is as logical level. But at physical level it will be stored in this way. That is, it will be stored in a one-dimensional array which is flattened from this 3D array. So as we can see, depth 0, row 0, column 0 comes first, depth 0, row 0, column 1 comes next, and so on. Again, one common thing over here is that the compiler will assign a address which is a random in nature to start this array. Once the array starts, which in this case is here, it will always allocate all the cells in a contiguous memory location. It will not happen that the array starts from here and the second element goes here. That will never happen. So I hope this would have given a solid understanding of how does an array looks like at memory level. So now that we have completed the theory part of an array, let's see what are the common operations that we can perform on an array. Let's talk about that in the next video. Thanks for your time. See you in the next video.